Alexa, turn on master bedroom.
Okay.
Hey, what's up? Nasir Malik here. I'm very excited today. I have been working on this project for a while and finally here is the first video. I guess home automation is still in early stages, so I started to do some research and finally came to the conclusion that I have to build one myself. Here it is. This is a small setup. I'm still developing these little boards. So let me explain what we have here. So I have Alexa here that hooked up to my network. I have this development board that is hooked up to my computer, to this programmer. I have this small ESP8266 version 01 chip. I have a relay that is hooked up. This is already flashed with the program. I'm going to ask Alexa to discover devices on my network, and it will going to discover this device, and then I will give commands to turn this device on and off. You should see this LED light going on and off, and here this relay. So this relay is for demo purposes. I'm planning to use solid state relays. I'll go through them in a little bit. So let's get into the demo. So I'm going to give a command to Alexa to discover devices, and it's going to go and discover this device on my network. Alexa, discover devices.
Starting discovery. This can take up to 20 seconds. If you have Philips Hue, press the button on your bridge.
So I'm going to wait. It takes a little bit of time. So even if you have one or multiple devices, it will discover it.
Discovery is complete. I found one smart home device. If your Philips bulbs were not discovered, please press the button on the bridge and rerun discovery.
So now it did discover this device on my network. So now I'm going to give commands, and I'm going to ask Alexa to turn these on and off. So let's give it a command to turn it on, and you should see a clicking noise from this LED. Clicking noise from this relay, and this LED should turn on. Alexa, turn on master bedroom.
Okay.
So as you can see, this light is on now. So I gave a partial command, so I'm going to give a full command now. Alexa, turn off master bedroom fan.
Okay.
So as you can see, the commands don't need to be full formatted the way they're flashed into the device. They could be partial. As long as they're a match, it will work. Otherwise, it will ask you which one to turn on and off. So this is very simple setup here. So I'm using a program to program this ESP8266, and this is very nice. I prefer these on instead of Arduino devices because the form factor and also the onboard Wi-Fi. If you look at the Arduino board, this is Arduino Nano. It doesn't have Wi-Fi, so for you to hook it up to your network, you need Wi-Fi. You can actually use Arduino with ESP8266 to provide Wi-Fi functionality, but since it has a programmer chip on it, so you can flash it and put your own programs. So I'm using this instead because the program size is very small. You can solder in more memory on it if you need more space. I bought a couple of these to experiment with, and I was very happy. If you look at the size with Arduino Uno, this is a very small form factor. So I got this, and this has two GPIO connectors, and they're not enough because I'm trying to set up fans and lights with like a sort of like a three-way switching kind of thing. So if I physically turn on and off a device, or appliance, I want this device to know that this is turn on and off, and then if I use Alexa to do it. So I want to be able to have it both ways. So two GPIOs are only good for one device. So I started looking and I found this one. This is ESP8266 12E version, and it has a lot more GPIO connectors on it. As you can see, let me see if I can close in. So this is so I really like this one. So this is better. So now I can hook up as many devices as the number of GPIOs are on this one. And if you look at it, the form factor is much smaller than the 01 version. So I wanted a small form factor so I can package this little small device and put it into, to the wall socket and be able to have it invisible, so not to know that the device is there, and then control it through Alexa. I'm planning to have these Alexa devices embedded throughout the house, and also planning a kill switch for them, so if I want to shut them down at the same time, so I can have them turn off and on at the same time. So let me walk you through some of the stuff I have. So this is a mechanical relay, and you can hear clicking noises when it turns on and off. So I started looking, I saw this relay. It's a pretty big hefty relay if you need to control a big load. If you look at it, it's like it operates between 3 to 32 volt DC, and it can handle 380 volts AC, and it's rated for I think 40 amps. Yeah. So this is something if you want to really control something heavy duty. Also, I looked at this. So this is the one I'm planning to use. This is rated up to 2 amp. So this is really nice. It's a solid state relay. The form factor is really small, and you can fit multiple of them on a board, and then you can put them inside the socket, and it's easy to put them in. I also started looking at some power supplies. This is a small cheap power supply. I have 3 of them. I started experimenting because these relay require 5 volts, and in the ESP boards they require 3.3 volts to operate. So there's a difference. So I got few 3.3 volt power supplies, and then some 5 volts, and I ordered some voltage regulator to drop it down to 3.3 volts. So see if I can use 5 volt power supply and drop it down to 3.3 volts and get this working. Also got a couple of different other power supplies that are packaged neatly, nicely, so there's a less fire hazard and stuff compared to these ones. They're really cheap. So I'm going to be playing around some of these things. These are some of the sensors I'll be using, humidity and temperature sensors with these devices. So we'll probably go through all of these. So this demo I wanted to show you just what I've been working on, and let me walk you through some of the boards I will be using. Arduino Uno, Arduino Nano, ESP8266 version 1 for experiment, ESP8266 version 12, FTDI USB to TTL programmer, and Raspberry Pi. These are the boards we will be playing around throughout the series based on what kind of project it is. If it is a media center, we'll be using Raspberry Pi, or if it's a hub for the IoT devices. If there's individual switches and devices that we need to control through Alexa or the smartphone, we'll be using ESP8266 version 1 or 12 based on how many GPIOs we need. So here's a carbon monoxide sensor that we'll be using, carbon dioxide sensor, relay to control devices, distance sensor. I'll be using these to open and close garage doors, or detect if the garage door open, close garage doors, and detect if the garage door is open and closed. IR sensor and transmitter and receivers to control TV, DVD player, receiver. Here are some of the projects that I plan to do. Control garage doors through smartphone and Alexa. Control lights and fan for each room with smartphone and Alexa. Monitor temperature, humidity, carbon dioxide, carbon monoxide for each room. And this is not limited. There are some other sensors that I'm planning to put in, but when we do this project, we'll walk through them. But these are some of the projects that I'm planning to do. Central AC and heating control with Alexa. So for this project, I'm gonna see if I can hook up to the existing Honeywell controller and hook that to Alexa using the ESP8266. If not, I may have to get something off the shelf. Control TV, PS4, Xbox, and receiver in each room with Alexa. Especially for the game room, what I want to do is I want to set it up so if I give a command to Alexa to turn on PlayStation 4 surround sound, so it should turn on my receiver, which is a 7.1 surround sound speaker system with the TV and PlayStation 4. And same thing goes for Xbox. So if I want to just play PlayStation on the TV and not using surround sound, so I should have a different command and it should just turn on the TV and PlayStation 4. So that's what I'm looking for to do. Pi 3 media server controlled by Alexa and smartphone. I'll be trying different XBMC like Kodi version or some other to see which one we can put on, and then we can control it through Alexa, selecting a movie or something like that. Build automation dashboard in the cloud. So basically you're gonna build an app in the cloud that you can access it through any device from anywhere. Plant watering sensor for indoor plants. So we have indoor plants in different shapes and sizes, and we want to set up some kind of jig in there that's invisible, hidden behind the plants, and it holds the water, and if we're away we can program it so it can detect the dirt and soil, how dry it is, and it can water it. So develop custom Alexa skills. So this is a very important part of this planning. All the Alexa skills that are out there, they are designed for specific use or purpose. So we're gonna take a look at it. If something that does not fit what we want, we're gonna go ahead and build Alexa skills ourselves and see if we can incorporate some of the stuff we want. So that is it for this tutorial. So next tutorial we'll take a look at ESP8266, how we can flash the ESP8266 and hook it up to our network and use Alexa to control it on and off. So we'll have this detailed step-by-step tutorial, so anybody who's even new with electronics should be able to follow it. So please let me know what you think. I will appreciate your feedback, and let me know what you like to see. Until next time, bye.